There's a permanent dark side of the moon. The phrase sounds mysterious and final. We're going to test it. We'll separate what the moon shows us from what the sun actually lights, and we'll explain why a side can be far yet not forever dark. This matters because the idea shapes how people picture space. It appears in headlines, lyrics, and movies, and it quietly misleads students learning the simplest rhythm in our sky. The fair version of the claim says one hemisphere of the moon always faces away from Earth. The unfair version sneaks in a second claim that the hidden side sits in eternal night. The myth spread because dark side once meant unknown side. Before the late 1950s, no one had photographed the hemisphere we can't see from Earth, so writers used dark as unseen, and the word never left. Media repetition cemented the phrase. It's short, dramatic, and a little spooky, which made it perfect for captions and album covers that prized mood over mechanics. Start with the basic mechanism. The moon keeps nearly the same face toward Earth because it rotates once for every orbit, a state called synchronous rotation. Synchronous rotation means an object spins at the same rate it goes around its partner. If you complete one spin per trip, the same hemisphere always points inward. Tidal forces set this up. Earth's gravity stretches the moon slightly, and over very long times that stretching and internal friction slowed the moon's spin until it matched its orbital period. Now connect rotation to light. Day and night depend on the sun, not on which way you face Earth. At any moment, half the moon is in sunlight and half is in darkness. The dividing line shifts across the surface as the moon moves, which means every location, near or far, cycles through day and night. A lunar day is the time from one local noon to the next. Because the moon orbits while it rotates, that solar day lasts about 29.5 Earth days. That long day length is the key. A spot on the far side basks in sunlight for roughly 2 Earth weeks, then sits in night for roughly 2 Earth weeks, just like places on the near side. So why do we never see the far side from Earth? Because geometry blocks it. The moon's rotation keeps the same hemisphere turned toward us, which hides the opposite hemisphere. Hidden does not equal dark. History offers the first big counterexample. In 1959, the Soviet probe Luna 3 took the earliest photographs of the far side and sent them home. Those images showed craters and highlands gleaming in sunlight. The scene looked unfamiliar because we'd never seen it, not because the sun never reached it. Modern missions have mapped the far side in detail. By the 2000s, orbiters had produced global coverage, and we learned that the far side carries more rugged highlands and far fewer large maria than the near side. That difference in terrain fooled some people into thinking the far side must be darker in light as well. Terrain is a geological story, not a lighting story. What about the phrase permanent darkness? There is a narrow case where it applies, but not to a whole hemisphere. Near the lunar poles, the sun skims the horizon at very low angles. Deep craters and crater rims can block sunlight year-round, creating permanently shadowed regions that stay extremely cold. Those pockets can trap volatiles like water ice. They are small, scattered, and mostly near the poles, nowhere close to a permanent dark side. Next, the phases of the moon, which are the source of much confusion. A phase is the portion of the sunlit half that faces Earth. At full moon, the side facing Earth is fully sunlit, so the far side sits in night. At new moon, the side facing Earth is dark, which means the far side is fully sunlit. That simple swap explains the myth's core mistake. People see the near side glowing at full and assume the far side must remain black forever, when in fact the lighting just flips every cycle. Here's a compact mental model. Picture the moon as a coin lit by a distant lamp. Whichever face points toward the lamp is day, and whichever face points toward you determines what you see as phase. Because the coin also turns as it circles you, you always see the same face. But the lamp still lights both faces across time. Another helpful nuance is libration. The moon's orbit is slightly tilted and not perfectly circular, so our view wobbles by a few degrees. That wobble lets careful observers on Earth peek around the edges over a month and a year. Thanks to libration, we can see about 59% of the lunar surface from Earth over time, not just exactly 50%. Libration does not change the day-night fact. It just widens our window slightly without breaking synchronous rotation. What about eclipses? During a total lunar eclipse, Earth's shadow falls on the moon and turns the near side a deep red. An eclipse is a temporary alignment, not ordinary lighting. It does not create a permanent darkness anywhere. It just interrupts the usual 2-week rhythm for a few hours. Let's separate correlation and causation in one clean sentence. The far side's unfamiliar look correlates with our viewing geometry and mapping history. It does not cause a lack of sunlight there. The strongest alternative explanation says maybe dark side is acceptable shorthand because dark often means unknown. That language choice still misleads because most listeners hear dark as unlit and then carry the wrong physics forward. As of recent studies, the only parts of the moon in near-permanent night are select polar hollows and cliff bases. Everywhere else, near and far, experiences a long, regular lunar day. What remains uncertain lives in those polar shadows. Scientists continue to refine how much ice lies in them, how it's layered with dust, and how it moves under tiny temperature shifts. Those open questions don't touch the myth's core. They refine resource maps for future missions, not the simple truth that the sun lights the far side half the time. Here's a practical rule of thumb for any permanent dark side claim. Ask whether the phrase describes being hidden from an observer or being unlit by the sun. If it's about visibility to you, it might be true that one side always faces away. If it's about sunlight, assume both sides take turns unless a polar shadow or special geometry is involved. Apply that rule to other worlds. Many moons around giant planets are tidally locked and always show one face to their planet, yet every point on those moons still cycles through long days and nights. Use the same check on catchy diagrams. When a label confuses far with dark, swap in precise words and see if the mystery survives. It usually won't. The night side moves. In short, the moon has a far side, not a permanent dark side. Synchronous rotation keeps one face turned toward us, but sunlight still sweeps across the hidden hemisphere every month. The distilled takeaway is simple. Hidden isn't unlit. Subscribe for more myth versus reality and tell us which space-worn phrase you want us to untangle next.